All right, guys, I want to pick up where we left off yesterday. We were working on this piecewise function. What I want you guys to understand, a couple things. When we deal with piecewise functions, the things that I have highlighted there, you have to always use those points, okay? Now, there may be, at times, more points that need to be chosen or more x values to be chosen, but you, by all means, have to choose and use the endpoints of the domains that they give you, the restrictions that they give you. Does that make sense? Okay. And when it's a linear function, that would be enough. Okay. But when it's a nonlinear function, a parabola or a cubic or maybe something that's exponential or logarithmic or even an absolute value, even though absolute value is linear, I think there are more points that are probably necessary. You're going to want to choose multiple x points, not just the two endpoints. Does that make sense? Okay. You want multiple input values so you get multiple order pairs, so you get the right structure of the graph. The other thing I want to talk about is the complexity of the functions that they use. Right now, we're in the first half of the second chapter of the textbook, so they're going along the ideas that maybe you're not familiar with logarithmic functions and how to graph them, or exponential functions, or trigonometric functions, or rational functions. Okay. However, those things could be incorporated as your rules. It could be your individual functions. Does that make sense? Okay. Why I say that is, right now we're working on this in Chapter 2. The next chapter we'll talk about different types of functions, and the following chapter another set of functions, and the following chapter another set of functions, and then we'll get to a test, our final. And our final will have a piecewise function on it that uses functions that exist from throughout the year, okay, or throughout the course. Does that make sense? So when you see this question on the final, it might not have just a linear function in it and a root function. It might have an exponential in it. It might have a logarithmic in it, okay? But whatever the function may be, the procedure on how to graph it is the same. Does that make sense? So logic is, if we can learn this, how to do this with, root functions, cubic functions, quadratic, linear, then you can insert any function after you learn that next type of function and progress that way. Does that make sense?
Yeah.
Blaze, you got a question?
Yeah. If we get good grades all year, but we fail the final,
the final is 30% of your grade.
So no.
Oh, yeah.
No, you won't.
So grades are weighted.
30% of your grade. So, depending on what you consider good for the entire year.
Say I get 100% all year, but I get a 0 on the final. Does that mean I got 70% in class? Yeah.
No, because.
Yeah. So
All right, so you will spend more time trying to figure that out than the time you spend on studying. So won't you take that time and put it to studying, and then we won't have to worry about figuring that out.
Well, I won't do that, but okay.
All right. We got G of X here. G of X is, we talked about how it's got these three different domains, right? Okay. Now I'm going to look at this blue domain. Okay, and I'm going to have to choose that value x to be an input. So I'm going to put it into the rule of absolute value of x plus 1. So I put -5 plus 1, I get -4, right? What do I get back then after I run it through the absolute value? Absolute value of -4 is 4, right? So when I chose -5, I got a y value of 4. Now, is this an open dot or a closed dot here at -5, 4? It is open. And that's because this was just a less than sign, right? So the idea there is that you really didn't plug in -5. You really plugged in -5.0 an infinite number of times and a 1. But that would eventually give you something like 4 point infinite number of zeros and a 1. Okay, so open dot. Now I'm going to try another point to the left of -5. So maybe I try negative 6. Negative 6 would be producing what output? 5. So negative 6 gives me a y value of 5. Now, here's where it's important to understand that x plus 1, that's a linear thing, right? Okay, so do I need any more points for this part? No. Okay. It's going to continue that behavior forever in that direction. Now, I need to have that arrow, because that arrow is going to tell me that I keep going on to infinity. Okay? Because that's what the domain of x is less than negative 5 says. If I get lazy, don't put arrows, I'm telling the person reading my graph that my graph actually stops. Okay? Now I do the pink one. Okay? Now when I look at the pink one, what kind of graph is negative 2? Is it linear or nonlinear? It's linear. It's a constant function, right? It's the graph y equals b. Okay, where we go find our y value of b, and then we've got a horizontal line through that. So this is linear. If it's linear and you look at your domain and you have 2 endpoints of your domain, okay, those are the points that you're going to use as inputs. So if I have negative 4 and I input it into this function that has no x to input for, what am I going to get back out? Negative 2. So at negative 4, I'm getting back out negative 2. It's an open dot because of the just less than symbol here. Now I'm going to try the other endpoint of 0. If I plug 0 in to this function, what do I get back? Negative 2. And it should be a closed dot in this case. And then because it's linear, I know that I can connect those 2 endpoints. I should be okay. All right. Now I get down to the green part. Okay, the green rule says you have to choose what x value first. Chuck, what x value I got to choose first? In the green here. Huh? Sure? You're positive. Why not? I told you before. Thank you, Peyton. So you plug 0 in. I plug 0 in, what do I get back? 0. Now, is this an open dot or closed dot then at 0, 0? It's open. Okay. Now, it's a square root. So yesterday we had our square root function. We talked about the parent function. We had the point 0, 0. We had the point 1, 1. We had the point 4, 2, right? Because this is nonlinear, it makes sense to have multiple points. If I just put 1, 1 on there and I start graphing, I think it's that, right? But it's nonlinear, so I need more than just 2 points. Three is okay. Put my arrow on there. And now I've got my piecewise function. Okay? The idea then, if this is a function, and all of these should be functions when we're done, we should pass the vertical line test. So, well, thanks. So as I move that through, it starts intersecting up top, right? Yep. Okay. And if can I have places where my vertical line does not intersect my graph at all? Probably. Yeah, we can have gaps. There's nothing wrong with that. Okay. Intersecting one time all the way through here. And now there might be concern there, but how many times do I really intersect my graph there? One time. Okay. Closed here, open there, so when we pass this through here. So if they ask me what is f of 0, if they were to ask the question, f of 0, what is the y value that goes with x being 0, what would you say? Would you say 0 or would you say negative 2? You would say negative 2. And the reason for that is because 0 belongs to that pink domain, right? It does not belong to the green domain. Okay? They're going to give you graphs eventually and ask you, you might have seen this in your homework already, they're going to give you piecewise functions, and they're going to ask you to evaluate at places like where I've got that green line, to where you got an open dot and a closed dot, and they're trying to see if you understand that aspect of which value is actually being plotted and which one's not. Okay? But then move that green line to the right, and we intersect only one time, so that thing does indeed pass the vertical line test. Okay? The other aspect of this question then is, can we, even though we evaluate at these kind of key points to get the graph, can we answer these questions that we have down here along the side? So it's g of -7. So if I have g of -7, what they're asking me is to first determine where I've got to put it in. G of -7 is in which one of these intervals? It's in the first one, good. So that's the one that we have to evaluate in. So I put -7 in there, and I get what back? 6. Okay. Now I'm going to go to the next one, and we're looking at 16. Which of these intervals does 16 belong to? Pink. So then put 16 in, and I get back 4, right? In order for this to be a function, there should never be question on whether it goes in the green one, the yellow one, or the pink one. Because if it was to go into both of those, or 2 of those, or all 3 of those, then we would have parts of our graph overlapping, and we'd fail the vertical line test. Does that make sense? So in regards to evaluating these things, there will only be one concise answer, because this is a piecewise function. Okay? So -1, well, I'll put -1 in. Which one of these? The yellow one, right? -1 is in that interval. So I input it into that, and I get -2 back. Okay? What about -4.5? Bless you. Okay, it doesn't fit. There's if I look at x being less than -5, that's that stuff, right? If I look at -4 to 0, that's that stuff. And if I look at x being greater than 0, it's that stuff, right? So the values that are unhighlighted between -5 and -4 tell me that those aren't values of my domain. Those things were skipped over. We got a gap there. -4.5 ends up in that gap. So there's no y values. There's no y values in this region here, right? So what do we say then for our answer? You could say no solution. That'd be okay. There's a better answer, though.
Undefined.
Undefined. And then the last one is that concept we already asked. If we're finding g of 0, I called it f earlier, but if we're calling g of 0, okay, we should realize that that's got to be in this yellow interval, and we're getting our -2 spit back. The doable? All right. So all I want to do today, guys, is a series of examples of how to graph these piecewise functions. And a lot of these end up being your kind of basic, either linear or quadratic. I think we'll do a cubic function. But I also want to, at the same time, recognize some key relationships that exist when doing this. So this one is going to have a pretty important conclusion when we're done here. Okay, it's not all that difficult of a piecewise function to graph. It says when x is greater than 0 or equal to 0, you're going to graph the line x. Okay, so if I've got greater than or equal to 0, so I'm going to choose 0 as my first input. Always have to choose the numbers that are defined in my domain as my input. Choose that as my first input, and I plug that in there. What do I get back? Take 0, plug it in, you get 0 back. So 0, 0 should be an ordered pair. Okay. Now, that thing is linear, right? So how many points do I really need to the right then of 0? How many more do I need to graph this line? I need one more. Okay. Now here's my thought. Okay. And if you've ever like worked construction or cut like a piece of like plywood or drywall or something like that, if I measure, let's say that this is an 8-foot piece of drywall, and it's 8 foot by 4 foot, and I want to cut this so that it's 8 foot by 3 foot. So I would take my tape measure and I'd measure down a foot here, right? Okay. Now if I measured down a foot like right there, and then took my straight edge, let's say I got like a long level or something, and I line it up against there, I could cut this and maybe get lucky to where I cut a straight line, right? But because these points are so close together, when I put my straight edge against there, chances are, like I'm going to cut that way. Does that make sense? My level still goes through those 2 points, but those 2 points are so close together that it incorporates human error. Does that make sense, everybody? If you've ever done this, Lucas, you ever done this with your dad? Okay, where are you going to put your, if you have marked down 1 foot here, I'm going to mark down 1 foot over here, right? And I put that gap now between my 2 points, and now it's going to be a lot easier to cut, okay? But the idea is I should minimize that human error, right? My argument to that is doing this. If I choose 1, and I'm going to graph a line, those two points are so close together, and when I put my ruler on them, or put my yardstick on them, and this is the idea of us using dots to identify points, but we know there should be no dot there, right? A point has no size. But if I do this, okay, would you agree that goes through both those? But when we start getting up here, okay, we're not going to be graphing points that are actually consistent with the line y equals x. So put distance between when you make lines, put distance between your points, your inputs. So I'm going to choose, instead of 1, 1, maybe I choose 4, 4. Okay? Puts a little bit more distance, right? Some people might say, well, I'm going to choose a lot of them, and that's fine. Still not, it's hard to graph on this tablet back here. But that's the idea. If I was cutting this piece of wood over here, or drywall, I'd probably put like 1 foot down there. I'd probably go in the middle somewhere, put 1 foot, and then go to this edge and put 1 foot. And if I can make sure that my line matches up with all 3 of those, then I can be guaranteed then that it's going to cut straight, right? Okay. But that's just some logical things as you guys are trying to, when we graph things, we want to eliminate, there's human error. We want to eliminate that as much as we can. Okay. Okay, so that's the yellow portion. Now I want to do this portion. If I'm going to do that pink portion, then what's the first input value I have to use, Chuck? 0. Good, Chuck. Okay. And if I put a 0 in, what's the opposite of 0? 0. Okay. So the idea here is it's a less than, right? So I should be putting, an open dot there, right? Does that make sense? I got a closed purple dot, and now I've got an open blue dot on top of it. Okay? So, how many points do I really have there at 0, 0? Just 1, okay? But what I need you guys to understand is that, like an open dot over a closed dot, or a closed dot over an open dot, the closed dot always takes precedence. It overrides. It's like, if I close my door and I lock it, is my door locked? Yeah. Right? Yeah. Okay. Open my door, lock it, and then slam it shut. Is my door still locked? Okay, so you got an open door and a closed lock, right? That's a great example. That's how, like, you guys have any like logic with or experience with Excel? Yeah. Okay. Have you ever locked like cells on Excel? Yeah. Okay. Well, they all start locked, and then when you hit the preserve key, okay, it locks all of them that were, so it's like a bunch of open doors that are locked. And when I shut those open doors, they stay locked and I can't touch them.
I don't like that one either.
Okay, never mind then.
It's fair.
Closed dot. Last class, fully understood that. Last class said that's a great example. All right. So open dot, closed dot, or closed dot takes precedence. Now I'm going to choose values that are to the left of 0. If I choose -3, plug it into my function. So when I plug -3, and this is something to pay attention to, that negative stays, right? So I plug -3 and I'm doing something like that. What's the opposite of -3? 3. If I try -5, what's the opposite of -5? 5. Okay? So now if I connect these, okay, what did I just create? Okay. So you guys are familiar, the V is the absolute value, right? So what we just figured out is that the absolute value of x is defined as a piecewise function. It is x when x is greater than or equal to 0, and is the opposite of x when x is less than 0. If you were to get into a textbook and they first describe what absolute value is, that's how they describe it. That's how they define that function, the absolute value function. Okay, they define it as a piecewise. So that's the kind of conclusion I said I want to, even though it's an easy piecewise to graph, we come across the conclusion that other functions that we use on a regular basis are actually defined, they are written, they're expressed as piecewise. Okay. Let's do, boring. Let's do this one here. Okay. Now, the way I structured this one, and I want to do this one intentionally, is because all the ones we've done so far, the domains have said if, or when, or where, and then they have a domain in set builder notation. So they're using the inequality symbol. What am I using here? Instead of inequality symbols, I'm making, or I'm using, what is that? That's interval notation, right? Okay. So it's not an ordered pair. Okay. It is expressing a domain in interval notation. So we can, if you want to, you can make the jump that turns into 3 is less than x is less than or equal to 6, doesn't it?
Oh.
Okay. Now, my hope is that we don't have to do that. We don't have to add that one extra step. Okay. You can, but you don't need to. All right. So I want to graph -2x plus 3 between 3 and 6. Okay. So I'm going to first plug in what x value, Chuck? 0. Did he say 0? Chuck, what x value did I plug in? 3. Okay. So -2 times 3 gives me -6 plus 3, -3. Okay. Open dot or closed dot? Okay. Okay. Now we'll plug in what number, Chuck? 6. And I plug in 6, what do I get back? -9. Open dot, closed dot? Close that. Now, I've told you we have to use the endpoints. We have to use those parts of the domains for your inputs. With that particular rule, do I need to use any others? No. Why not? Because what? How do you know? That's linear, okay? When linear rules, you only need the endpoints, okay? And you know the other ones are going to fall in line. Now, if we do this one, okay? There's a couple ways you guys can do these. I would hope that you use the more efficient way, meaning that you remember from last year transformations a little bit. Okay? If I had x cubed, remember x cubed yesterday? Okay, so I gave you this graph, and we had 0, 0 on it. We had 1, 1 on it. We had 2, 8. -1, -1, and -2, -8, right? My hope is that we've committed that to memory. When I see x cubed, that jumps out right away. Well, let's think about what that rule says. It says x cubed plus 1. Well, x cubed is how you get your y values, right? Well, this is saying your y value is x cubed plus 1. So your y value is 1 more than what the y values were for x cubed. So if I look at -2 on x cubed, the y value is -8, right? For x cubed plus 1, the y value is going to be -2, or sorry, x value is -2. The y value would be -8 plus the 1. Does that make sense? That's the behavior of that plus 1 right there. It's going to add 1 to your y. So what's that going to give me? -2 comma -7. Open dot or closed dot? Why?
Because it's a bracket.
Okay, good. So we got a bracket here, so it's closed. All right, so now I'm going to use 1, right? Okay, so I plug in, so thinking about 1, 1 off of x cubed. Okay, so on x cubed plus 1, it's going to be 1 comma what?
Is it 2?
It's 1 comma 2.
Ooh.
And it's a closed dot, right? Does everybody kind of understand that idea? These are my x cubed y values. So then add 1 to each of those, and now I've got the y values for x cubed plus 1. Whenever we add, listen, whenever we add a constant to our function, it's just going to either slide it up or slide it down. What? That bee knows that if he stings him, he's going to die.
Yeah, but why would why did Lucas just turn around and like it was nothing, like it's his bed.
Okay. Now, is that enough? Is that enough points for me to graph?
Yeah.
We sure?
No, you need one more.
I need one more? If I may, well, let's think about this. If I go one more, I might, by coincidence, use the one that lines those things up. Look at this. Are these, listen, if I go one more, let's say I choose 0, I'd be 0, 1, right? Okay. Let's say I chose -1. If I go -1, it would be at a y value of 0, right? Let's say that those were the only 3 that I chose. What's that look like? Those 3 points themselves are collinear, are they not? So when you have something that's nonlinear, there can be situations where you graph 3 points because it's not 2. You say, well, a line needed 2, so I need 3 for nonlinear. You might still get the linear aspect of that particular graph. Does that make sense? So when it's nonlinear, the more points that you plot, the better. Okay? So we've gone from what? 1, 0, -1, -2. That should give us enough to graph this thing and realize that in order to get to that bottom point there at -2, -7, we have to curve a little bit, right? It can't be a line. Is that doable?
Yeah.
Okay, so the next one says -3 between -5 and -2. What kind of line? I said it. That's a line, right?
Yeah.
Now, what kind of line is it? Oh, that's redundant.
Which one?
Both. What kind of line is it? Somebody said linear. Okay, well, lines and linear, I know. So a geometric aspect of lines was that they always have to be straight. Is it vertical or horizontal? It's horizontal. Okay, so I'm going to have at -5. At -5, I'm going to have an open dot. At -2, I'm going to have an open dot. And then I'm going to connect them. Okay? Now, the idea here, guys, how many times, if I were to put a vertical line through -2, how many times does that vertical line intersect my graph? Once, right here, right? Okay?
Why is there a black line right there?
Hold on. Yeah, thank you. Thank you. So now, what was the question? Why did I choose those numbers? What do you mean, what numbers? Because when I plug in -5, there is no, so this -3 here is y equals -3. So when I have a line, because it's f of x, right? But we know f of x is representing our y values. Another way of interpreting it is if I plug in this -5, there's no variable to plug in -5 for, right? Okay, so when x is -5, the output I get is -3. If I plug that one in, okay, -2, and I plug in -2, the output again is -3, and that gave me those 2 points. But then the logic is, okay, well, use any number that's in between those. Use -4. Plug -4 in. My output's -3. Plug in -4.5. My output's -3. And every time that you plug one of those in, your output's going to be -3. And that's what these points on that horizontal line are referring to. So the same aspect then happens, or the same idea happens when I look at this one here. From -8 to -5, -8 to -5, we're at a height of +3, right? So it should be an open dot there, open dot there, and I connect them. Okay, so open dot now is, if I put that vertical line there, and these were both open dots, is that okay for a graph? Yeah. Okay, you can have gaps, right? I want to give you a way of doing this in GeoGebra. Now it can get a little messy with GeoGebra, but what we have to do is we have to type in the word if, okay? And then we see that we're actually going to use that middle one. It says if, and then you give a condition, okay? And the condition is actually the domain. So it's going to be the, this first one is going to be 3 to 6. And then I hit comma, and the then will actually be the rule that I want to use. So, all right, if, now we have to write this in stat builder notation. So if 3 is less than x is less than or equal to 6, that's how you type in less than or equal to on any kind of computer platform to get the equality part of your inequality. So that's my condition. So if the x values fall within that range, it said comma then, so I wanted to evaluate at 2x plus 3. Okay? Now if I hit enter, it will graph just that portion of that line. Okay, now I don't want to hit enter because I want to continue doing this. The next part said comma else. So comma else means, what else do you want to do? Okay? If you've got other things that need to be done, well, I'm going to say, well, else would be, okay, if I'm not between 3 and 6, I want to do this one here, right? So I'm going to write comma if, and then write the condition for this. -2 is less than or equal to x is less than or equal to 1. And then I want to write my then, so x cubed plus 1. Now this is where it kind of starts to get messy because we got another condition. So I'm going to say, so inside of this if, I've got another else. Yeah, that's equality there. Yes, so it's a nested if then. Huh? Oh, I'm sorry. I see what you're saying. The only thing about when I graph the less than or equal to is going to be later on if I ask it to evaluate at certain points. You're not going to see on the graph open dots or closed dots. So now I'm going to write comma if, and now I've got another condition. If we're between -5 is less than x is less than 2, then I want to use negative 3. Does that make sense, everybody? And then I got another condition, so I'm going to write comma, if x is between negative 8 and negative 5, I'm going to write 3. Okay, and hopefully we've got everything here. I'm going to scroll through and see that my parentheses match up. Can you guys see that those parentheses turn green? So it's just matching up parentheses. And we should have them all. And if I hit enter, we see then that is the graph that we were interested in. Now, what have I got going on here? Let's see. Now, this is going to be weird the way that they show these down here. I'm not 100% sure. These are and symbols. Okay. Why is this between? So I think I've got something typed in wrong here that's giving me this. Okay. But does the rest of it, neglect where I've got my cursor, does the rest of it look like what we graphed by hand? Okay. Now, the reason I write it that way is so that it would give it to me with this, like you guys have written it in interval notation, or not, written it in function notation, piecewise notation, right? That's how it was presented. You don't have to do that. Okay, if you want to do it this way, if you want to go if 3 to 6, and then you go comma negative 2x plus 3, and then hit enter, that's fine. And then you're going to type in g of x. I'll just do another if, and it'll automatically give me g of x. Let's say we wanted, what was it, x cubed plus 1 between negative 2 is less than or equal to x less than or equal to 1. We had x cubed plus 1. You kind of see how we're getting these different pieces. Does that make sense? And you can go with the negative 3 and the 3. And then get that final graph that way. Does that make sense? That's obviously a little bit easier, I think, but it's not going to give you that function notation when you're done. Okay? Or that piecewise function notation. Desmos, if you're a fan of Desmos, a little bit different way of typing it in. And you can even do this on your TI-83s and 84s, but it's a real pain in the butt on your TI-83 and 84. And to be honest with you, I forget how to do it. But if you Googled like Boolean notation for a TI-83 or 84, it'll tell you how to do it. You got to use parentheses and the logic key and stuff like that on your calculator to get that done. But if we go Desmos, all you have to do on Desmos is type in, like, I wanted negative 2x plus 3, right? I believe if you hit then curly brace, okay, which is shift and then your button next to P, and then type in what we're going through, between 3 and 6.
Yeah.
So I'm going to hit the less than key, and then I hit equals to, and you see how it puts the less than or equal to for me? And then X, and I'm going to say less than, and then hit the equal sign, and then say 6. And I graph it, and you see how then it just gives me that little portion, right? Okay. But if I don't put, I don't know if parentheses will do it. Yeah, if I don't put the right braces around my domain, it doesn't know what to do. Does that make sense? So this thing is programmed to say, okay, when user puts curly brace in, that means we're going to start restricting our domains and looking at the graph that way. Okay. I'm just seeing something here. You don't have to write this. 3 if x is less than 0. Nope.
Whoa. He's just a pro, man. He has a son. He's just a bro. Like, you won't see his
All right, do you guys feel comfortable with piecewise functions? We're going to move on. We're going to move on tomorrow to something else, okay? But piecewise functions are going to be something that we continually, they pop up over and over and over again, okay?
Did you guys get him out there? They won't open the door. Come on. There's the door. Or the window.